Measurements and dimensional analysis. Measurements provide the information that is the basis of most of the hypotheses, theories, and laws in chemistry. Every measurement provides three kinds of information: the size or magnitude of the measurement, which is a number, a standard of comparison for the measurement, a unit, and an indication of the uncertainty of the measurement, and that's based on how many significant figures are in that measurement. When you write answers in this course, it's very important that you not only put the number, but you also put the correct unit. Number and unit are key to getting the correct answers for everything that you do in this course. The unit system for science measurements is based on the metric system, and that's called the International System of Units, SI units. Important SI base units for length is the meter, mass is the kilogram, time is second, and temperature is in Kelvin. The standard of length. So the definition of a meter, established by the International Agreement in 1983, is the distance that light travels in a vacuum in 1 out of 299,792, 458 seconds. The speed of light is that in meters per second. The standard of mass, the kilogram, is defined as the mass of a block of metal kept at the International Bureau of Weights and Measures in France. A duplicate is kept at the National Institute of Standards and Technology near Washington, D.C. The standard of time, the second, is defined using an atomic clock as the duration of 9,192,631,770 periods of the radiation emitted from a certain transition in a cesium-133 atom. And the kilogram is a measure of mass, which is different from weight. The mass of an object is a measure of the quantity of matter within it. The weight of an object is a measure of the gravitational pull on that matter. Consequently, weight depends on gravity, while mass does not. There are some prefixes and some prefix multipliers that you should be aware of. Now, if you look at your chemistry aid sheet, hopefully you all had a chance to print out the chemistry aid sheet, there are some useful conversion factors, and prefixes are written on that sheet as well. So here you can see prefixes and their meaning and the multiplier, including the exponent. Units of length. So in the metric system, the units of length, kilometer down to a nanometer. There are many other prefixes that you can use here that give you different denominations, but we have the basic ones that we'll be encountering in this class. Examples of equivalent measurements of length. 1 kilometer is equal to 1,000 meters. How do we know that? Kilometer, 1,000 meters. 1 centimeter is 0.01 meter. Here you go. Centimeter, cm, 0.01 meter. 100 centimeters is 1 meter. 1 nanometer is 10 to the negative 9th meter. 10 to the negative 9th nanometer is 1 meter. Choosing prefix multipliers. So choose the prefix multiplier that is most convenient for a particular measurement. Pick a unit similar in size or smaller than the quantity you are measuring. A short chemical bond is about 1.2 times 10 to the negative 10 meter. Which prefix multiplier should you use? Pico is 10 to the negative 12th. Nano is 10 to the negative 9th. The most convenient one is probably the picometer. Chemical bonds measure about 120 picometers. You will rarely have to make this decision in this class. A derived unit is formed from other units. Many units of volume, a measure of space, are derived units. Any unit of length, when cubed raised to the third power, becomes a unit of volume. Cubic meters, cubic centimeters, and cubic millimeters are all units of volume. So dimensional analysis, converting one unit to another. First, you want to read. You want to identify the known and unknown. Then you're going to plan. You're going to identify the principles or equations needed to solve the problem. Then you're going to set up. Use a dimensional analysis to solve the problem, canceling all units except the unit needed in the answer. Calculate. Calculate the answer and round for significant figures. Remember, in this class, we're safe to use 3 sig figs for all calculations. Check. Does your answer make sense? For most conversion problems, we're given a quantity and some units and asked to convert to the quantity in another unit. These calculations take the form as follows. Conversion factors are constructed from any two quantities known to be equivalent. We construct the conversion factor by dividing both sides of the equality by 1 inch and canceling the units. The quantity 2.54 centimeter to 1 inch equals to 1 and can be used to convert between inches and centimeters. In solving problems, always check if the final units are correct and consider whether or not the magnitude of the answer makes sense. I have an example from a colleague that told me he was having students calculate the dose of Valium that would be needed to give to a patient. After doing the calculations, it turned out that the patient would actually need 5,000 liters of Valium. Now, 5,000 liters would fit in a swimming pool, so giving that to a patient would probably definitely kill them, wouldn't fit in their body at all. So that's where you go back and say, does my answer make sense? Does this calculation that I just performed make sense? Conversion factors can be inverted because they are equal to 1, and the inverse of 1 is 1. So the solution map for converting from inches to centimeters is as follows. The solution map for converting from centimeters to inches is as follows. And both of those are equivalent to 1. Each step in the solution map should have a conversion factor with the units of the previous step in the denominator and the units of the following step in the numerator. So following the solution map, 194 centimeters, if we wanted to figure out what that is in feet, this is how you would set that up. So calculate the number of kilometers in 80,700 meters. So let's investigate what we have here. So we're starting with this. And it wants to know how many of this. So we're going from here to here. And what is our conversion factor? Our conversion factor from meters to kilometers is 1,000 meters is equal to 1 kilometer. And if you're not sure of that, that's in your chemistry aid sheet. 1 kilometer is equal to 1,000 meters. So what do we do next? We start with what we know. What we have is 80,700 meters. And I like to use parentheses because it helps me make sense of the situation. So 80,700 meters, because I have meters on the top, I'm going to put meters on the bottom because eventually I want my units to cancel out. And I'm converting to kilometers. km goes on the top. Now I'm going to fill in the numbers for my conversion factor. We have 1,000 meters, so I'm going to do 1,000 meters. We have 1 kilometer. And we're going to do the math. When you see parentheses like this, our units, m and m, cancel off. And we have kilometers as our answer. And that's what we wanted to get to in the end. you always multiply across the top and divide away the bottom. So this becomes 80,700 divided by 1,000. So your answer is 80.7. Why is it not 80.700? Because if you remember, I told you you can round every answer in this class to 3 sig figs. And this basically just goes through everything that I just covered. Calculate the number of centimeters in 25 meters. So we know that we're starting with 25 meters. We want to get to centimeters. So going from meters to centimeters. What's our conversion factor? There's 100 centimeters in 1 meter. Start with what we initially have, 25 meters. Meters is on the top, so we're going to put meters on the bottom. We're converting to centimeters. So now we're going to plug in our conversion factor. 100 centimeters is equal to 1 meter. We multiply by the top, divide away the bottom, and when we do that, that cancels out these units. We're left with centimeters. 25 times 100 divided by 1 is just 25 times 100, so that becomes 2,500. And since there is 2 significant figures, I'm fine with you leaving it in 2 significant figures. If we wanted to put it in 3 significant figures, the only way to do that would be converting to scientific notation. It would become 2.50 times 10 to the 3rd centimeters. Which one of these calculations is set up properly to convert 35 millimeters to centimeters? So all of them are starting with 35 millimeters. We have millimeters on the top, so we have to have millimeters on the bottom. But what's the correct conversion factor? This is the correct conversion factor. Convert 12 inches to centimeters. Start with what you have, 12 inches. Identify the conversion factors. And then write the equations so that the last unit is the unit you must convert to. So here we go, 12 inches. We want to get inches to centimeters. So inches, so that the inches can cross off. Your conversion factor is 1 inch is 2.54 centimeters. You're going to multiply across the top and divide away the bottom. So 12 times 2.54 gives you 30.48 centimeters. Rounded to 3 sig figs is 30.5 centimeters. Convert 45.2 inches to centimeters. So go ahead and pause the video, work out the math, and then you can unpause it to get the answer. Okay, 45.2 inches. Because inches is on the top, we got to put inches on the bottom. We're converting to centimeters. We're going to plug in our conversion factor. 1 inch is 2.54 centimeters. So then we go 2.54 times 45.2, and that gives you 114.808. 0.4115 centimeters to 3 sig figs. Remember to always have a number and a unit, and if whenever possible, 3 sig figs in your answer. So answers need the number, the unit, and the measure of precision, which I'm telling you for this class you want to aim for 3 sig figs. Convert 1.24 quarts to milliliters. So go ahead and pause the video, and then I'll go through the answer with you. Okay, so we're starting at quarts, and we want to end up with mils. But there's no direct conversion factor on the chemistry aid sheet that goes straight from quarts to mils. But what does happen is it goes quarts to liters and then liters to mils. So this is going to be a two-step problem. So quarts is going to go to liters and then liters to mils. So we have 1.24 quarts, and we're going to put quarts on the bottom. And like I mentioned, we have to go to liters first. Then from there, we're going to put liters on the bottom, and we can finally go to mils. So how many quarts are in a liter? Well, according to the chemistry aid sheet, 1.057 quarts is 1 liter. So that's just our conversion factor. And we're going to put in another conversion factor to get us from mils to liters. So 1 liter is 1,000 mils. Now what we're going to do is we're going to multiply across the entire top and then divide away the bottom. We do not want to round in between steps. So we're not going to do this part and then the next part. We're going to go straight across the top, get a number, and divide it straight across the bottom. So 1.24 times 1 times 1,000 gives us 1,240. And then the bottom is 1.057 times 1 is just 1.057. And when we do the math, 1,240 divided by 1.057 is equal to 1,173.13 milliliters. Because the quarts canceled out, the liters canceled out, and we're left with mils, and that's what we wanted to end up with. Now to 3 sig figs, this would be 1, 2, 3. Look to the right. We're going to keep the 1,170 mils. All right, and we'll go through one more problem together. So go ahead and pause, and then we will go through this problem. Okay, according to the chemistry aid sheet, we don't have a direct conversion factor from tons to grams. So what we're going to do is go tons to kilograms, then to grams. So 2.2 tons, tons on the bottom, kilograms. Our conversion factor says 1 ton is 907.2 kilograms. And then we're going to go kilograms to grams. There's 1,000 grams in 1 kilogram. We're going to multiply everything on the top, divide it away by the bottom. Since the bottom is all ones, we can just ignore that. That's 2.2 times 907.2 times 1,000, and we get 1995840. So here we go, and if we want to round to 3 sig figs, that would go 1, 2, 3. We're going to round up. 2.00 times 10 to the 6th grams. When converting quantities with units raised to a power, the conversion factor must also be raised to that power. So in order to obtain a proper conversion factor, you'd have to make sure both sides are raised to that power. So density. Why do some people pay more than $3,000 for a bicycle made of titanium? For a given volume of metal, titanium has less mass than steel. We describe this property by saying that titanium, 4.5 grams per centimeter cubed, is less dense than iron, 7.86 grams per centimeter cubed. The density of a substance is the ratio of its mass to its volume. So density equals mass over volume, or D equals M over V. Density is a physical characteristic of a substance that can be used in its identification. And it's temperature dependent. Which substance is most dense? Well, you'd have to actually calculate. So if the mass is 10 grams, you would have to calculate the volume to get the density. So for example, a sample of liquid has a volume of 22.5 mils and a mass of 27.2 grams. To find its density, we use the equation D equals M over V. So the density is equal to 27.2 grams, the mass, divided by 22.5 mils, the volume. And that's going to give us 1.21 grams per mil. We can use the density of a substance as a conversion factor too, between the mass of a substance and its volume. For a liquid substance with a density of 1.32 grams per centimeter squared, what volume should be measured to deliver a mass of 68.4 grams? Well, if this is our conversion factor and this is what we know, what volume is what we're trying to find out? So we start with 68.4 grams. We put grams on the bottom. Centimeter cubed is our volume equation that we're going to use. Now the conversion factor here, it's 1.32 grams per 1 centimeter squared. So when we do the math, you multiply across the top, divide away the bottom. 68.4 divided by 1.32. That gives you 51.8 centimeter cubed, and that's our volume, and that answers this question. So this table is a useful table for helping solve some homework problems. So if you need the density of any of these substances, you can find it here in this table. For the most part, densities will be provided to you in homework assignments. So determine the density of 35 mils of ethyl alcohol with a mass of 22.2 grams. So density equals mass over volume. So that's equal to 22.2 grams over 35 mils. How did I know to put the grams on top and the mils on the bottom. Well, grams is a mass and mils is a volume unit. So if we do 22.2 divided by 35, we get 0.634 grams per mil. So our unit is derived from the units within the problem. Determine the density of 82.9 kilograms of a substance that has a volume of 2.22 liters. So this is a mass, this is a volume. D equals M over V. 82.9 kilograms over 2.22 liters. And we get 37.3 kilograms per liter. Determine the mass of 35 mils of ethyl alcohol. The density of ethyl alcohol is 0.789 grams per mil. So D equals M over V. They give us the density. It's 0.789 grams per mil. And that's equal to, they want to know the mass, so the mass is unknown, and the volume is 35 mils. You want to make sure that your units match. So as long as mils and mils match, we know that our mass is going to end up in grams. So now we have to solve for x. To solve for x, we have to multiply by 35 on both sides. 35 divided by 35 crosses that out, and we multiply by 35 on this side. And this is your basic algebra solving for x. So that's 35 times 0.789. That gives us 27.6 grams. Determine the volume of 35 grams of ethyl alcohol. The density is 0.789 grams per mil. So now they give us the mass and they want to know volume. So 0.789 grams per mil is equal to mass over volume, 35 grams over x. So to solve for x in this instance, first of all, we have to get x on the top. So we're going to multiply both sides by x. That's going to cross out these x's, and we're left with 0.789x equals 35. Now we have to isolate the x. We're going to divide by 0.789 on both sides. So 35 divided by 0.789 equals 44. We're rounding it to 3 sig figs, so 44.4. And our unit is grams. Okay, just a couple more problems and we're going to wrap up this lecture here. So determine the volume of 92.2 grams of a substance that has a density of 1.02 kilograms per mil. So remember I told you to check your units. So now we're talking about a density that's given in kilograms, but they're giving us a volume or a mass in grams. So the first thing we have to do is convert to our density units. So we're going to start with D equals M over V. So 1.02 kilograms per mil equals, the mass has to be in kilograms. So we're going to take 92.2 grams, convert this to kilograms. So there's 1,000 grams in 1 kilogram. And then our answer is 0.0922 kilograms. So that's what we can put in for the mass. 0.0922 kilograms. And we're going to solve for milliliters. Now, just like I did before, we got to solve for x. First, we got to multiply both sides by x. That becomes 1.02. X equals 0.0922, because these x's cross out. Then we're going to isolate the x. So we're going to divide away the 1.02 from both sides. So 0.0922 divided by 1.02 gives us 0.090, and we're going to round to 3 sig figs. And what's our unit here? So the volume unit is in milliliters. So you can go ahead and attempt this one. And the answer is A. And then this one. So this one, 109.35 grams sample of brass is added to a 100 ml graduated cylinder. Here's a graduated cylinder. It's 100 mils capacity, but it has 55 mils of water in it. When you add that sample, it increases the water level to 68 mils. So the amount of water that's displaced is the volume of the brass. So you would do 68 minus 55.5 mils to give you 12.5 mils as your volume. And now you just take the mass divided by the volume, and you get that 8.75 grams per centimeter cubed.